Good afternoon. Welcome to my laboratory. That's another NE-2 ring oscillator that I just made. And let's see, there's the first ring oscillator there. There's the second one. They both have the same schematic. The reason that they're flashing differently, this one's flashing in a star pattern, and this one's flashing in a circle. And the only difference is the way the capacitors are hooked together. The wiring schematics are actually the same for both of these. They're just geometrically arranged a little bit differently. And they are right now running off of the output of the Bedini North Pole motor, and it's running both of them actually. And here's the voltage and current values. This is the lowest voltage that I could get both of these ring oscillators working reliably. I've put 2 more magnets in the rotor, so now we have 4 magnets in the rotor, and that smoothed it out considerably. You can tell it's running quite a bit more quietly. And here is what the scope trace looks like. Okay, and there we're at 50 volts per division. We have a 10x attenuating probe on there, and the time base is at 10 milliseconds per division. Okay, so we're looking at 50, 100, 130, 120 volts spikes, and then this little notch down here is the actual coil drive pulse, and when the coil shuts off you get this spike. Because of where I'm monitoring the circuit, this is actually reversed. Negative is in the up direction and positive is in the down direction. So this is a positive pulse to the coil here of 12 volts, or 50 volts per division, and then, 16 volts. I thought it looked a little bit higher than 12. Okay, and then this is the spike that comes when the coil shuts off and the magnetic field collapses. And that spike is what's being channeled to the high voltage components of the circuit, the neon ring oscillators. And also, if you charge a battery, that's what's going to be charging the battery, is that spike. Okay. Now without the load, that spike can go up to 1,000 volts or more. It goes way off the screen. Alright, so let's see what the frequency is. If I count the middle 8 divisions, that would be 80 milliseconds, and I have 1, 2, 3, 4, 5, 6, 7, just over 7, call it 7.2 cycles in 80 milliseconds. So going to the calculator, let's see, I go 7.2 divided by 0.08, that's 80 milliseconds, equals 90. But we have 4 pulses per rotation, so I divide that by 4. Divide by 4 equals, oops, I pushed the equals button too many times. So times 4 equals 22.5. Okay, so that's 22.5 complete revolutions per second. So times 60 equals 1350. So we're going 1350 RPM on that motor, rotor motor right now, based on the pulsations on the oscilloscope, if I did the math right. Okay. Did I do that right? 1, 2, 3, 4, 5, 6, 7.2 in 80 milliseconds. Alright, so 7.2 divided by 0.08, that's 80 milliseconds, equals 90 divided by 4 equals 22.5 times 60 equals 1350 RPM. And it's running the 2 ring oscillators. Oh, schematic for the ring oscillator. Sorry. Over here somewhere. Yeah, there. That's the schematic for the neon ring oscillator. And depending on how you arrange it physically and how these capacitors are hooked up, you can make it do a circle, or you can make it do a star, and that's that. Thank you for watching.